all the properties have just been lost. Okay. So let's look at another example. Log base 3 of 27 x squared y to the 5th. So what property can we use here? No. Number one says if you're multiplying the same bases here. Oh, I see it. Yeah, with the second set of properties, right, of logarithms. So since they're all multiplied, we do what with them? Yeah, so take 3 log base 3 of 27 plus log base 3 of x squared plus log base 3 of y to the 5th. Right, since we cannot have exponents, these come out in front. So it's 2 log base 3 of x plus 5 log base 3 of y. Are we done? We can't go any further with these guys since we don't know what x and y are. But we can fix this first one. What's 27 made up of? 3 times 9. 3 times 3. 1, 2, 3. So log base 3 of 3 cubed
Is that 3?
Right, and so now since it has exponent, that comes in front. Just write everything else out. Log base 3 of 3 becomes 1. So it just becomes 3, right? And there's your answer, expanded version. Let's look at another example with a radical. Log base 2 of 12 x to the power, let's make it 5, make it bigger, over square root of y. Log base 2 of 12x to the 5th divided by square root of y. Now, first thing, since we have fraction, let's get rid of the fraction. The way we do that, since we're dealing with logarithms, we take the numerator, 12x to the 5th, minus log base 2 of square root of y. That's the first thing we do. This first one is a multiplication, 12 times x to the 5th. So we can split those up. Log sub base 2 of 12. Since multiply, we add log base 2 of x to the 5th minus log base 2 of square root of y. Bring an exponent. So So log base 2 of 12 plus 5 log base 2 of x. Now the first and last one, what can we do with those? The square root of y is a 1/2 exponent. Very good. So we take that one, and 12 we know is going to be made up of 6 times 2, 2 times 3. So it's made up of log base 2 of 2 squared times 3. And the last one is y to the 1/2 power. Here, since this was multiplied, we can split those up. Log base 2 of 2 squared plus log base 2 of 3 plus 5 log base 2 of x minus, here's an exponent, so it goes out in front, 1/2 log base 2 of y. We're almost done. We can't do anything with the last one, the 5 log base 2 of 3. We can't do anything. Only thing we do is with the first one, and then we're finished. What can we do with it?
Becomes 2.
Yeah, just take the exponent, move it in front, and then we have, then we have log base 2 of 2, which we know is going to disappear. Base 2 of 3, 5 base 2 of x, and 1/2 log base 2 of y. Log base 2 of 2 is 1, so we just get rid of it. There's our answer. Well, it's long, but was any part of that stuff really that difficult? Besides the radical x, remembering that radicals, remember this property of radicals. Remember this property of radicals. Whatever's inside this v goes on the bottom. Whatever's inside goes on top. Yeah, then whatever, these other ones like log base 2 of 3, we can put in the calculator. And the rest of that stuff we can do anything with. All right, let's see. So these are just simplifications. Let's look at a couple of examples of solving logarithmic and exponential equations. Here's one. Log base 3 of x plus log base 3 of x minus 2 equals log base 3 of x plus 10. We have an equal sign, so we have to treat both of these sides separately for right now until we simplify it. On the left-hand side, we have a plus. So we can combine both of those numbers. They're both log base 3s. So I have x times x minus 2. Equals log base 3 of x plus 10. Now, since both sides are log base 3, we can just get rid of the log base 3s. So what we really have, in order for these guys to be equal, these have to be equal. The operations have to be equal. So x times x is x squared. Negative 2x equals x plus 10. Since it's quadratic, we have to make it equal 0. So we subtract x from both sides. X squared negative 2x minus 1x is negative 3x equals 10. Subtract 10 from both sides. So we have x squared minus 3x minus 10 equals 0. Let's see if we can factor these. So it's made of x times x. The second sign is a minus, so it means opposite signs. One's plus, one's minus. The bigger number will be negative. What times what is 10? When you subtract them, you get 3. Yeah, 5 and 2. 5 times 2 is 10, 5 minus 2. So 5 gets the negative and 2 gets the positive. Set both of those equations equal to 0. We get our 2 answers. But we're not done. Always check your answers. Can we use negative 2? So if we look at our original equation, log base 3 of x plus log base 3 of x minus 2 equals log base 3 of x plus 10. If we plug in negative 2 for this first one, it's undefined because you can't have a log of a negative number. So we cannot use a 2. Can we use a 5? 5 minus 2, so we have log of 5. 5 minus 2 is 3. Log of 3. 5 plus 10 is 15. Multiply these on the left side since they're added. Log base 3 of 5 times 3 equals log of 15. Log base 3 of 15 equals log base 3 of 15. So it works. So the only answer we have is x equals 5. You always have to make sure, you always have to multiply your answers or check your answers. Let's look at another example. What's that? Yeah. Which part are you looking at? Yeah, because they're the same log base 3s and they're added, so I can combine them as 5 times 3. Okie doke. Let's make a bigger one. Log base 5 of x plus 2 minus log of 5 of x equals log of 5 of 2x minus 1 minus log of 5 of 3x minus 12. What do you think we have to do first? Our first wave is going to be what?
Take those first ones on the left side and make a fraction out of it.
Right. They're both going to be fractions, but both have minuses between them. Log base 5 of x plus 2 over x equals log base 5 of 2x minus 1 over 3x minus 12. Well, since they're both log base 5, the only way they're equal is if we have the operations are equal. X plus 2 over x is equal to 2x minus 1 over 3x minus 12, since they're both log base 5s. No, these are equations. They have to stay together. Anytime you have a plus or minus, that's an equation that has to stay together. So since we have fraction over fraction, we cross multiply to get rid of the fractions. We have x plus 2 times 3x minus 12, x times 2x minus 1. Now FOIL. X times 3x is 3x squared. X times negative 12 is negative 12x. 2 times 3 is positive 6x. 2 times negative 12 is negative 24. Is equal to x times 2x is 2x squared. X times negative 1 is negative x. Always combine like, whenever you get rid of parentheses, always combine like terms. So we have negative 12x plus 6. Since 12 is bigger, we're subtracting 12 minus 6 is 6x. So it's negative 6x minus 24 equals 2x squared minus x. It's quadratic, so we have to get it equal to 0. Subtract 2x squared from both sides. 3x minus 2x is 1x, so it's x squared. Bring down everything else. Minus 6x minus 24 equals negative x. Add 1x to both sides. X squared, negative 6 plus 1 is minus 5x. 24 is equal to 0. Now let's factor this. X and x. The second sign's a negative, so one's a plus, one's a minus. The bigger number is negative. What times what is 24 when you subtract them, you get 5. 8 times 3. 8 times 3 is 24. 8 minus 3 is 5. So 8 goes to the negative. 5 goes to the positive. So x is equal to negative 5. X is equal to 8.
Should that
Checking
be,
your, what's that?
that should be a negative 3 there. Oh, never mind.
No.
Wait, x plus,
Oh, 3. Yeah, I'm 3.
okay.
Yeah. So now, checking your answers. If we go back to the original equation, here's a log base 5 of x. Which one of these cannot work because it's negative at 3? So the only answer we can use is x equals 8. And plug it in there, you'll see it works. Okay, one more example, and then we'll look at the homeworks. Log base 3 of 8x minus 15 equals 4. So how do you think we're going to attack this one?
You can log out the 8x and the 15.
No,
Can't-
So we're gonna turn that into a fraction. Side. First,
no. The fraction only works when we have log of x minus log of y. You could make them into a fraction.
yeah, we're gonna first spread it out into.
You can't. This is minus signs inside parentheses, so you can't split this up.
It's not actually.
It's not multiplying or dividing two separate logs. It's one log of this. So we can't do that. Let's go back to the basics, to the first one.
You can log out the 4, so it'd be log 3, 4. Log 4
Well, let's just take the base
base.
and push it over. So it's 8x minus 15 equals 3 to the 4th. I threw that one in there because we've been doing all these other log property ones. And sometimes we have to go back to the first one we ever learned was converting it to an exponential equation, which is what we just did here. So what is 3 to the 4th? 3 times 3. So 3 times 3 is 9. 9 times 9 is 81. Add 15 to both sides. 8x equals 96. Divide both sides by 8. 8 goes into 9 once with 1 left over. 8 goes into 16 2 times. The answer is 12. Okay, fortunately, I wrote down the homework problems for those first two sections, 8.4 and 8.5. So 5.4, the first question is log base 22 of 22 times 484. You're right. So it's going to be log base 22 of 22 plus log base 22 of 484.
22 goes to 1.
That goes to 1. Now 484. So we have 2 times 242. 2 times 141. 141 No, 121 is 11 times 11. So it's log base 22 of 2 squared and 11 squared. So it's 1 plus, but 2 times 11 is 22 squared. We do 2 times 11 times 2 times 11 is 22 squared. So this number goes out in front. Log base 22 of 22. This becomes 1. 1 plus 2 is 3. So what do you think the most difficult part about this logarithm stuff is? Just knowing the properties and when to apply them and how to apply them, right? And that's all there's, and there's only not too many of them. We only have really 5 that we have to think about. This one here saves us a lot of time. Same base, same. That's one of them. You know, if you multiply them, you can separate them, or if they're separated, you can always put them back together. Let's look at the second one. ln of g times r. Expand that for me. As far as you can go. Since it's multiplied, it's ln g plus ln r. There's your answer. Log of z to the 13. Yeah, 13 goes out front, so it's 13 times log z, and that's as far as you can go. Number 4, ln of the 5th root of 8. Remember, whenever you have a radical, the root, whatever's inside of v goes on the bottom. So what we have here is the 5th root of x is equal to x to the power 1/5. So we have ln of 8 to the 1/5 power. So 1/5 ln of 8, and use a calculator for ln of 8.
They didn't want you to go that far in the,
Yeah, they said let's put it as a product. Because the rest of that part is just putting it in the calculator and hitting enter.
one of the ones I was gonna ask, but
ln of c, ln base c of a over 4. Since it's a fraction, we can do what? Add or subtract? Right, so we subtract the top number, log c of a minus log c of 4. That's as far as you can go. Log of x over y. Yeah, so it's just another subtraction, log x minus log y. This is using the properties. Log base d of x to the 7, y to the 7, z. Expand that. So first off, since they're all multiplied, we can separate them by adding them. So it's log base d of x7, log base d of y7, and log base d of z. That's the first step. So get rid of the parentheses. Now the next step is these first two have exponents, so they become coefficients. So 7 log base d of x plus 7 log base d of y plus log base d of z. And that's as far as you can go. Log base t of 13 plus log base t of 64. So since it's addition, we combine them by multiplying, right? Since log base t of 13 times 64. Uh, 64 times 13, 12, 19. So it's 2, 3. So it's log base t of 832. Log of 100,000 minus the log of 1,000. All right. Since they're subtracted, we're going to do what? Now make it a fraction. So it's log 100,000 divided by 1,000. So what's that? Can we simplify that? Yeah, cross out the zeros. So it becomes log of 100. One hundred divided by 1 is just 100, but we're not done yet. What is this log? What's the base? It's base 10. Log base 10 of 100 equals some number x. Move the 10 under the x, so we have 100 equals 10 to the power x. In order to compare these, we have to have the same bases. 100 is the same thing as 10 squared. 10 to the power 2 equals 10 to the power x. So x equals 2. So the whole equation equals 2. Again, I don't know how it wanted. If it just wanted the log, that's what they want. But if they wanted the answer, that's what they want. Yeah, you're right. It's just memorizing the formulas, the properties of exponentials and logarithms, because you have to put them both together. Number 10. 10 to the power log x minus 5. So what do you think? Which one of the properties do you think we can use here? We're going to use that property. If the base of the log and the base of this are the same, they cancel each other out. Because the exponent is log base 10. So these guys cancel each other out. The answer is x minus 5. E to the power ln of z. Ln is what? Log base e of z. Same property. Since the base and the base are the same, they cancel. It's just z. Ln of e to the power 20t. Bring the 20t out in front. Ln e. Right, we know this is 1 because ln is log base e of e. So that becomes 1. So it becomes 20t. So far, so easy. Getting better. I don't want to say easy. Don't say it's just trivial, but just looking back at, are these really that difficult? Did I do anything that was mind altering? Yes. No, I didn't. Let's look at, just keep on going. 5.5. 4 to the power x equals 64. We know we have to solve that because there's an equal sign. So what's the first thing you have to do when you get an equation like this? No. We have to compare both of these numbers. What is 64 made up of? Two times 32. 32 is 2 times 16. 16 is 4 times 4. 2, 2, 2, 2. But we have a base 4 on this side. We have 1, 2, 3, 4, 5, 6. So 64 is 2 to the 6th. Or it's the same thing as 4 to the 3rd. 4 times 4 times 4. So x has to equal 3. Now, could we have made them? We had 4x equals, what I did originally was 2 to the 6. Okay, they're not the same bases. Can I make them the same bases? What is 4 made up of? Yeah, it's 2 squared to the power x. The rule of exponents say whenever you have a power to a power, what do you do with them? Multiply them. So it's 2 times x is 2x equals 2 to the 6. Now we have the same bases, so we only have to look at the exponents. 2x equals 6. X equals 3. Either way works, which whatever is easiest for you to see. But if you're going to go all the way down to the smallest, then you have to make sure you have the same bases before you go any further. This is number 2. 3 to the power 5x is equal to 27. Right. 27 is 3 times 3 times 3. So it's 3 to the power 5x equals 3 to the power 3. Since the bases are the same, we just have to look at the exponents. 5x is equal to 3. Yeah, oh yeah. So the answer is x is 3/5. So the first step, when you have this kind of things, always try to see if you can get the same bases and just compare the exponents. Number 3, 6x is equal to 2x plus 1. Can we make them the same base? So not really. There's possibilities you have no real solutions. Let me see. Let me go, what number? That's section 5. .5. That's the question number 3. Let's look at. Oh, let me switch you guys over. Uh-oh. So they're going to want us to take it further then. So that's what I was wondering is, are they going to let us take it here? Now, since they're different bases, we can take the ln of both sides. Because since our variable is the exponent, since the variable is the exponent, the only way you can bring it down is by taking both sides to the same log. ln is the easiest one I can think of. I mean, if you wanted to, I could do log base 2 or log base 6. If you wanted to, we could do that as well. No, but so now with the exponents come out in front, we have x ln 6, x plus 1 ln 2, Get rid of the parentheses. X ln6 x ln2 plus ln2. Let's get all the x's to one side. X ln6 minus x ln2 equals ln2. We're trying to solve for x. So we have x's on both of these. What can we do with these x's? We can factor out the x first. Because we're solving for x, we have to get x by itself. So now we can make it into a fraction. X ln 6 divided by 2 6 divided by 2 is 3. Divide both sides by ln3. Since we're dividing, we can subtract them. And that's why I said. Okay. Yeah, we did that. We did take the common log or natural log of both sides. So we did that. So I think they want us to work it out step by step by step.
Yeah, they want you to put a number in. It's going to be 0.6309, I believe. 6309, I'm sorry. Or,
Oh, I'm sorry. Yeah, I put the wrong number.
yeah, I may have punched in the wrong numbers.
So they want us to put an actual number. Let's see. Let me see you guys on this page. Yes. On calculator. We have ln of 2 divided by ln of 3 equals 0.6309. Interesting. Where's that? There. Do the same thing here. 5 to the power 4x plus 2 equals 3x. This is question number 4. 5, 4x plus 2 equals 3x. So first thing is we have different bases and we can't get them simplified. We take the ln of both sides. That brings the exponents out in front. Distribute, get rid of the parenthesis there. So we have 4x ln 5 plus 2 ln 5 equals x ln 3. Move all the x's to one side. Move this one over. So we have 4x ln 5 minus x ln 3. Get rid of the 2 ln 5. We only want the x's on one side.
We actually subtract those. Become 3x ln. Oh no, because the 5 in the rear.
Okay, so we can't, unlike the last one, we can't factor out since they're not the same. Well, there's nothing, these aren't the same, but they both have an x in common. I factor out the x and divide both sides by the parentheses. Let's see what that's going to equal. Oop. My calculator. So on the top, have negative 2 ln 5 times ln 5 divided by 4 times ln 5 minus ln 3 . $6,029. I put a 3, not a 6. Why would I put these numbers? 6029.
Rounded to 3 decimal places. 60288, so 603.
Stupid instructions. Right, log of x equals -3. This is question number 5. Log of x equals 3, right? Ah. All right. So what do we do here?
3 over and set it to 0.
We're solving for x. We have to get rid of the log. It's log base 10.
That's
10 to the power -3. Since it's negative, it's 1 over 10 to the third. So there's your answer. I'm gonna make sure, I'm gonna plug these in there and make sure they work. .001. Number 6. ln x equals 8.
log base E.
All right, so it's log base e of x equals 8. E to the power 8 equals x. Let's just calculate right. So it's 8. I'm sorry. E to the power 8. $2,980.95798. How many decimal places they want it? Type exponential equation with positive exponents. Oh, so they just want e to the 8. Seven. Log 36 of 1 over 6 equals x. So it's 36 to the power x, 1 over 6. Looking at the right-hand side, 1 over 6 is the same thing as 6 to the power -1. So we want base 6. We want it to be base 6. So 36 is made up of 6 times 6, which is 6 squared to the power x. Power to a power you multiply. Since they're both base 6s, 2x equals -1 divided by 2. X equals -1/2. Oh, yeah. So again, this one took a lot of moving around, but on this right-hand side, we have 1/6. Put the 6 on top. We have 6 to the negative first. So we know our base is going to be 6. Fortunately, 36 is 6 times 6, was 6 squared to the power x. -1 divided by 2. Number 8. Log base 4 of 4x minus 8 equals 3. Let me switch over. Okay. So it's 4x minus 8 equals 4 to the third. Four to the third is 64, right? Add 8 to both sides. $72. Divide by 4. We're saying that x is equal to 18. Okay, just put it into exponentials. Move the 4 across the other side, drop the log. Number 9, solve for x. Log of x plus log of x minus 21 equals 2. Right, since there are 2 logs, so it's log x times x minus 21 equals 2. Right, so this is log base 10. So move the 10 across. Very good. Drop the log. So we have x minus 21 equals 10 squared. Get rid of the parentheses. 10 squared is 100. Move the 100 to the other side by subtracting. Now factor x, opposite signs. What times what is 100? When you subtract, we get 21. 25 times 4 is 100, 25 minus 4. And the bigger number has to be negative. So our possible answers are -4 and 25. Can't be -4 because of the first one. So the answer is 25. X equals 25.
Why can't it be -4? Because
Because right here in the first one, if we plug it in the first one, we have log of -4, and you can't have a negative input. But remember, the graph of a log looks like this. We cannot input x being negative. The answer can equal negative, but you cannot have a negative inside that part. Our domain is x is greater than 0.
Thanks.
You're welcome. Yes, you're welcome. That's a very good question, because we've had negatives before. Why can't we do that? But that's the reason, because it was our input that time. This next one, now we're getting larger. This is number 10. Log base 3 of b plus 32 minus log base 3 of b plus 5 equals log base 3 of b. Oh yeah, so the first part, let's combine these two. Since there's subtraction, we put into a fraction. Log base 3 of b plus 32 over b plus 5 equals log base 3 of b. Since they're log base 3 on both sides, the only way they could be equal is if these operations are equal. So b plus 32 over b plus 5 equals b. Get the b plus 5 off the bottom, multiply it to both sides. B plus 32 equals b plus 5. Get rid of the parentheses. B times b is b squared plus 5b equals b plus 32. It's quadratic, so it has to be equal to 0. So we subtract b from both sides, and we subtract 32. So 0 equals b squared. 5 minus 1 is positive 4b. B and B, the second sign is negative, so positive, negative, but this time the bigger number is positive. What times what is 32? When you subtract them, you get 4. 8 times 4. So that means our answers are -8 and positive 4. So which one can we not use?
So -8 doesn't work in the second half. Log of 3b plus 5.
Or on the other side, yeah. We have, if -8 plus 5 is -3, can't use that. Log base 3 of -8, can't use, so we can't use that. So we're saying if we do have an answer, it's going to be that one. And we could test it here. B plus 32 over B plus 5 equals B. 4 plus 32, 4 plus 5, does it equal 4? So 36 over 9 is 4. Yep, so B equals 4 is our answer. B equals 4 is our answer. And number 11. Log base 9 of x is equal to 1 minus log base 9 of x minus 8. So what do you think we have to do here first?
So if we just get rid of the log base nines and compare what's left.
Well, but there is a possible way, but right, yes, we'll look at that in a second. But let's move this one over to the other side. Let's move all the x's to one side. So we add log base 9 of that. So we add log base 9 of x minus 8. Log base 9 of x plus log base 9 of x minus 8 equals 1. Because it's added, we multiply them. Log base 9 of x minus 8 equals 1. Convert to exponentials because that's what we've been doing in the past. This 9 comes over here, so we have x minus 8 equals 9 to the power 1. X squared minus 8x equals 9. X squared minus 8x minus 9 equals 0, subtracting 9 from both sides. X plus and minus because it's negative. What times what is 9? When you subtract them, you get 8. And 9 gets the negative. So our answers are -1 and 9. And since we have this log base 9 of x, we cannot have a negative. So the x equals 9. And so that's our answer. So our answer is x equals 9. All right, everybody. That does it for chapter 5, actually. What I'm going to do, I'm going to stay behind and I'm going to redo what I forgot to press play, record the first time. The principles, yeah, which is the important. So I'm going to call it the properties file, the properties, yeah. So, okay, I hope I didn't go too fast. I hope everybody sees that it's not that impossible. I mean, it's just a lot of stuff. Seven properties you have to memorize and how to apply them, when to apply them. It's like a big puzzle.
I actually like this better than chapter 4.
Yes, this is much better in much better in chapter 4.
Definitely.
Drive safe. Yeah, so yeah, I do too. This is, to be honest with you, this is my favorite chapter because it is like a puzzle. What do I do next? What do I do here? And it's just straightforward. Chapter 4, you have way too many moving parts. All right, so if you need anything, I will get these to you this evening. I will go home. I'll create that new property one. I'm so sorry, but I'll get that done.
Just want to confirm that 5, 6 is not, we don't have to do that.
I believe, yeah, there's no 5, 6 because after 5, 5, we have our exam. Let me see. Yeah, you're looking at my screen. So yeah, after 5, 5 is the exam. And then if you look at it, chapter 6, do you guys remember what systems of equations were? When you deal with substitution, elimination, that kind of stuff? That's what chapter 6 is all about. Substitution, elimination, and graphing to solve systems of equations. And then Kramer's rule does that much faster. So we're pretty much at the end of the semester. Yay. But yeah, I will have, hopefully we'll have a week or two if you guys want to ask any questions whatsoever. And I'll be here to help y'all. All right.
Okay, appreciate it.
Thank
You're
you.
Thank
very
you.
welcome. I was going to say drive home safely, but enjoy your evening.
You too. Thanks.
Bye.
Bye-bye.